Hello, I am Pankaj Sharma from Brainleague Learning. In this short lesson, we will build an intuitive picture of the CPU, the central processing unit. It is the brains of a computer. It executes instructions, performs calculations, and controls how data flows. First, the major components. We will focus on 4 pieces. 1. The arithmetic logic unit. It performs addition, subtraction, bitwise operations, and comparisons like greater than or equals. 2. The control unit. It fetches instructions from memory, decodes their meaning, and sends signals so that the rest of the chip does the right thing. 3. Registers. These are tiny, very fast storage locations inside the CPU that hold data values, intermediate results, and the next instruction address, often called the program counter. For cache memory, a small, extremely fast memory close to the CPU that stores recently used data and instructions, so we avoid slower main memory. Every instruction follows a repeating cycle. Fetch, decode, execute, and write back. Let's connect the CPU to main memory and walk through one instruction visually. Fetch. The control unit reads the next instruction from main memory into the instruction register. Decode. The control unit interprets the bits, what operation, and which operands. Execute. The arithmetic logic unit or another part performs the operation. Write back. The result is stored into a register or into memory. This runs billions of times per second. What makes a CPU fast? 3 big ideas. First, clock speed, measured in gigahertz, counts how many cycles per second we can run. Second, number of cores. Each core runs its own instruction cycle. So more cores means more parallel work. Third, caches. Level 1, Level 2, and Level 3 cache sizes matter because hitting cache avoids slow main memory. Now, a concrete example. Suppose we need to compute 3 plus 5 and store the result in register R1. 1. Fetch the add instruction from memory. 2. Decode it as add the contents of R2, and R3 store into R1. 3. Execute. The arithmetic logic unit reads R2 equals 3, and R3 equals 5 and computes 8. For write back, the result 8 is stored into R1. Then the CPU proceeds to the next instruction. That is the high-level view of a CPU, its parts, the instruction cycle, and what affects performance. If you want to dive deeper, we can explore pipelines, out-of-order execution, and how caches are organized.